Section 3.1, Introduction to Rational Functions. Part 1, Introduction to Rational Functions. A rational function is a function that is the ratio of polynomial functions. Said differently, R is a rational function if it is of the form R of x equals P of x divided by Q of x, where P and Q are both polynomial functions, and Q is not the zero polynomial because we cannot divide by zero. Determine if the following are rational functions. If we have f of x equals 3x squared minus 5 divided by 7x cubed minus 2x squared plus 3x minus 1, both the numerator and denominator are polynomials, so yes, this is a rational function. For g of x equals 3 squared of x plus 2 divided by x squared minus 5x plus 3, the denominator is a polynomial, but the numerator is not. We have square root of x, or x to the 1/2 power, and remember that the powers on the variables of a polynomial must be non-negative integers. Finding the domain of a rational function will be a big part of analyzing any rational function. The domain will include all the real numbers where the denominator is not equal to 0. We cannot divide by 0, so we can't have the denominator equal to 0. So on this first function, f of x equals x plus 3 divided by x squared minus 16, if I factor the denominator, that can help me find where it's equal to 0. So I know that x cannot be 4 or negative 4, because those would make our denominator equal to 0. In interval notation, if you need to write it that way, it would look like negative infinity to 4, union negative 4 to 4, union 4 to infinity. So everything except for 4 and negative 4. If we look at part B, g of x equals x plus 3 divided by x squared plus 16, when is that denominator equal to 0? If I set x squared plus 16 equal to 0, I know that can't be equal to 0, so x squared cannot be negative 16, or x cannot be plus or minus 4i. Now 4i is not a real number, and when we're talking about domain, we're talking about real numbers. X squared plus 16, if x is any real number, will not ever be equal to 0. The smallest x squared could be, if x is any real number, is 0, and then we add 16. So it cannot be equal to 0. So our domain is all real numbers, or in interval notation, negative infinity to infinity. Part C, h of x equals x plus 4 divided by x squared minus 16, is similar to part A, but the numerator is different. The numerator does not affect the domain. The numerator of a fraction can be equal to 0, just the denominator cannot be. So again here, our domain is the same as part A. X cannot be 4 or negative 4. However, notice that if we were to factor that denominator, we could cancel out, like factors, the x plus 4, and we get 1 over x minus 4. If 1 over x minus 4 was our original function, then x could be negative 4. But because of the original function had an x plus 4 and an x minus 4 in the denominator, our domain still is x cannot be 4 or negative 4. Find the x and y intercepts of a rational function. So the x-intercepts are where y is equal to 0, or where the function equals 0. So what makes a fraction equal to 0? If you think back to when you first learned fractions, if we have 0 in a numerator, say 0 over 8, that is 0. So the numerator of a fraction is what makes the fraction equal to 0. So in this case, x plus 3, our numerator, equals 0 when x equals negative 3. So our x-intercept is the point negative 3, 0. That is the only thing that makes our numerator equal to 0, so that is our only x-intercept. The y-intercept is when x is 0. So if I have 0 plus 3 over 0 squared plus 16, I get 3 over 16. So the y-intercept is the point 0, 3/16. Part B, if f of x is 3 divided by x squared minus 16, our x-intercept is where the numerator is equal to 0, but 3 is never equal to 0. No matter what x is, 3 will be equal to 3. So there is no x-intercept. The y-intercept, again, is when x is equal to 0. So 3 divided by x squared minus 16, which is negative 3 over 16. So the y-intercept is the point 0, negative 3 over 16. Looking at these two functions, They're similar. The first one we have an x plus 3 in the numerator. The second one we have an x plus 4 in the numerator. So the first function, our x-intercept, is the point negative 3, 0, because that is what makes the numerator equal to 0. And the y-intercept, again, is when x is 0, so we have 0, negative 3/16. The second function, we talked about the domain here. We know that x cannot be 4 or negative 4. But if I factor and simplify, my numerator is x plus 4, denominator is x plus 4 times x minus 4. These cancel, and I'm left with 1 over x minus 4. To find the x-intercept and the y-intercept, once we find the domain, we're going to cancel out whatever we can cancel here. In this case, it was the x plus 4. And now find our x and y-intercept using this simplified version of the function. So there is no x-intercept because that numerator 1 will never be equal to 0. The y-intercept, again, is when x is 0, so 1 over 0 minus 4, which is negative 1/4. So we have the point 0, negative 1/4 for our y-intercept. So once we find the domain and we cancel out any like factors, after that, when we're talking about the rational function, we're going to use the simplified version to find other parts of the graph.